The outcomes for this chapter are going to be converting percent and decimal numbers, setting up percent problems using percent formula, use proportion to solve percent problems. That's going to be a big deal because we've been using proportion already. Calculate percent change, solve single trade discount problems, and calculate percent strength problems. And number 6, 5.6 will be very useful for people who are doing chemistry as well. Alright, so let's get started. I'm not going to do the pretest, I never do. So the first thing we want to talk about is converting percent to a decimal. And I'll start by reviewing an example that they have. Here. So, the example that they give, they say a whole number has a decimal to the far right of the final digit of the number, and what they're saying is right here. B right here. See the decimal located there. And what they do here, they're showing you, basically if you're 75%, you take the decimal and move it 2 places to the left, it becomes 0.75. The key about percentage is that it's always out of 100. And it always annoys me when you hear this first on TV, like, this will give you 110%. I bought a razor in Montreal, and it was, oh no, sorry, it was a toothbrush, and it was, removed 151% more bacteria. Okay, it's a lot more than 100%. Maybe it's going to take some of the stuff I don't even have yet. Nice toothbrush, I love it. In any case, so basically, when we see 76%, for example, actually what that means is 76 out of 100. And if we were to divide those numbers, that's where this comes from down here. No problem? Awesome. This is not going to be too difficult because it's something you've most likely already seen and dealt with already some. Let's quickly have a run through here. So in here, you can see that the percentages are all there. Make this a little larger. So jumping really quickly through this, and given what we just said about moving the decimal place, it becomes very simple to turn it into a decimal. By just going 65 becomes 0.65, 52 becomes 0.52, this becomes 0.75 and 1/2. You can take that to another value if you wanted to. Turn it into a decimal. 1/2 is actually 0.5, so it'll be 0.755. Down here you'll notice that it's going to be 0.28. And if we wanted to down here, we could have 0.445. But the book shows you 1/2, so we leave it like that. And that's pretty well it. Just the decimal places. No sweat. And converting decimal to a percent is kind of like the opposite in the direction, and it looks like this. To convert a decimal to a percent, shift the decimal point 2 places to the right. So down here you'll see we have, this is where I showed you a minute ago, the 3/4 becomes 7/5. So basically what happens, 14 3/4 is actually 14.75, and moving the decimal places 2 places to the right, we get 1475%. What that means, in the previous example we did here, here, we were talking about putting the 76 divided by 100 and converting percent to a decimal. Down here, it's the opposite because we're actually going 14.75 multiplied by 100 to get our percentage. So whether you multiply by 100 or just move the decimal place 2 places to the right, which is easier, that's converting into a percent. Awesome, so far so good. Let's have a look at some of these examples. Oops. Sorry. I saw something funny. Anyway, I'll tell you about it in a second. I'm back here. This morning I was getting ready for breakfast and getting prepared to come in here. Phone rang, and of course when my house phone rings, it's usually a pretty big deal because no one ever calls that number. Right? If they want to call you, they just call your cell. Or I have a cell, my wife has a cell, my son has a cell. So no one calls the house no phone, except her mother. I think once in a while my mother would call the house phone. Nobody uses it. This morning the house phone rings. Answer the phone. This is guy on the line saying, "Hi, I'm from Windows. You have detected viruses on your system. You need to have it scrubbed so we can actually remove the viruses so it doesn't affect your software." So of course I know right away this guy is trying to scam me. So instead of just getting angry or upset, I decided to just keep him on the phone. He said, "Can you go sit by your computer? I'm making breakfast." I was like, "Yeah, okay, I'm by my computer." He's like, "Can you see the CRT button?" "No, don't see that button. Where's that button?" I'm like, I kept him going on about 10 minutes. And finally he got fed up with me and said, "You know, sir, who owns this computer? Is this your computer?" I said, "Yes." He said, "What do you use it for?" I said, "I play games on it." So he said, "Well," he said, "I have to go," but he hung up on me. That's pretty funny. He won't call me back anymore. I like doing things like that. It's kind of fun once in a while when you have time. Anyway, that's just me. Little side note. In any case, converting these decimals to percents is exactly the opposite of what we just did. Let's have funny stories once in a while. Take the math edge off. In any case, again, this is just as simple as before. Move the decimal 2 places to the right, and this becomes 37.5%. This becomes 564%. This one looks a little tricky, but it becomes 920%. We don't have a 0, so we just put one in. Easy. Down here, we do the same thing. We throw in a 0. This becomes 1080%, and down here it becomes 7.6%. So again, just moving the decimal 2 places to the right, and we convert it into a percent. It's just all we're doing is multiplying by 100. So this is using proportion to solve percent problems. And the key is right here. I'm going to show you. This piece right here, that is the key for this part of using the proportions to solve percent problems. You memorize that, even if you don't memorize it, just ask me, I'll put it on the board or tell you. I don't really worry about memorizing it. But that's the key to solving percent problems. And I've never memorized this way because it's backwards the way I like to see it. It's actually what I like to say. It's like I usually write it as just because I find it easier to remember. I just usually go is over of equals percent over 100. And you're like, what? That doesn't make sense. Let's have a look at an example. And when we look at an example, it'll make sense really quickly. So I'm going to cover this over. Maybe I should move it down here in case you want to see it later. And it doesn't have not how the book does it, so I'm just going to keep it the way the book does it. But I just find that the blue part there easier to remember from my perspective. So you can see this percent up here. I'm just going to hold it a bit more. Right here, the percent over 100 and equals is over all. We get a question like this down here. Basically, you'll see it says 25% of 75. So the percent, you see right here, goes in the percent part right here. And of 75, see the of piece here goes where the of is over here. Therefore, we put it down here. That's what 25 is do. Make sense? Basically, you're just filling in the blanks where they go based on the formula. Looking at the next one, you can see the percent over 100, same formula. This one says what percent, so this time what percent basically means this is what we're looking for this time, so we don't know that part. Of 75, so the 75 goes down here in the of place. See? Is 18.75, and the is on the top is where the 18.75 goes. So again, it's just reading the question closely and picking out the is over of and percents and putting them in the equation. Once we get it done, it's just a matter of cross multiplying, and we're all experts at cross multiplying now. Down here we see 75 is what percent? Sorry, 75 is 25% of what? So looking at that here, we say over here 25% is on the top. The 75 is sorry, 18.75 is. I was reading that as question 18 that time. 18.75 is, and the is up here, so that goes on the top, and the x on the bottom this time. So basically, what I'm trying to show you is that you use this equation here. Everything sets up nice and easy. So that's key for proportions using percent. Let's try a few of these practice ones. First question here says, what is 75% of 200? where do these numbers go? I have 100 here, that's always stays there, that's fine, that's going to stay right here. Where does the 75 go? Any ideas? Well, it's 75%. Percentage is right here. So 75 has to go up here. And this of 200, the of is over here in the bottom. So the 200 goes here. This is our x. And then we cross multiply. Down here it says 10 is what percent, so what percent we don't even know yet, so that's going to be our x value right there. 100 is here, 10 is, 10 goes up here, of 125, and 125 goes down here. And then again, we cross multiply, and so on. So what I'm just doing here, a quick little review of like where to place these numbers in the formula, so you know where to do that. Once you get that done, it's just cross multiplying as well as before. So we see here we have 8.5%, so the 8.5 goes up here, of 224, the of is right here, 224 goes down here, and this one here is the x part right now, we don't know. Pretty cool. So that's how the formula works, not a problem. So I'm going to look at this. This is more of an applied part right here. So percents are big things in healthcare. So percent problems in healthcare. To solve a percent problem in healthcare, you need to be aware that the problem may include whole numbers, fractions, or decimals. The skills used to in percents draw on the foundation that you have in these areas. So basically it looks like this. You'll see here that it says 15%. 15 is what percent of 300. We know our equation, our formula. It's going to be percent over 100 and is over of. So the 300 goes on the bottom and 15 goes on the top. And we cross multiply, it's going to be 300 times x. 100 times, right here, 100 times 15. And yeah, they didn't do the full thing, they just said 1500 divided by 300. So what they did here, they didn't fully cross multiply, they just said the x value is equal to 15 times 100 divided by 300. Which equals 1500 over 300, and that's where they get their 5. And it's 5%. So it's pretty much the same deal, but it's more applied problem. So let's have a look at this first question here. There's some more examples like this. So down here, let's have a look at number 1. So we have a portion here that says 35% of 120 is what number? So we have a formula that we know, which is actually going to be percent over 100 equals is over of. So the 35% goes on the top right here. So I have 35 over 100. And you see here it says of 120. So the of is right here. So 120 goes on the bottom. And the is our x value. So it's not that challenging really, once you put the numbers in. Then let's cross multiply, so it's going to be 35 multiplied by 120 divided by 100 equals x. So we do this. $35 times 120 divided by 100 equals 42. So our x is 42. If you get, okay, I'm going to show you a shortcut that does the same thing. You see right here what I did was I cross multiplied, so the 120 came up here, multiplied by the 35, and I got 35 times 120. I'm just going to come down here and stretch it down a bit so I can, oops, my bad. So it becomes, if I use the calculator, it's going to become 35 times 120. It's going to equal 4,200. So that equals 4,200 divided by 100. And that's where 42 comes from. But there's another way to do this, which is kind of simpler and easier if you want to try it this way. And I'll just show you the shortcut way. Okay. So we know that it's going to be, we're coming back to this part right here. We'll take this piece and start from here. Okay? Show you what happens. So down here, if I have my 35 over 100 equals x over 120. If I wanted to first, I could just simplify this piece over here. In other words, what I mean is I could just convert the 35 into a decimal right away. Like, what? So basically it looks like this, 0.35 equals x over 120. Don't start that again today. And then it comes down here like this, where I can go 0.35 multiplied by 120 equals x. And you'll see, if I put it in my calculator, if I go 120 multiplied by 0.35, you'll see that you get 42. Same answer. And that's why it works. So if you want a shortcut to determining that answer, you take a percentage of a number, multiply the decimal part by that number, and you get the percentage. So 35%, 120, take the 0.35 times it by 120, and you get your number. But if you don't like that, or you find it confusing, you can go back to the old reliable, set up the equation, cross multiply, and life is good. Let's try another one of those. Let's try that one. 50 is what percent to 48? So we know again, setting up our equation, we have percent over 100 equals is over of. So it's looking for the percent, so that's going to be our x value. 100 down here. The 50 is the is part, and the 248 is the of. And then we cross multiply. Or basically, instead of doing that, we'll use the shortcut way I showed you before. Take this one, multiply by that one, and then continue on. So it's going to look like this. X equals 50 times 100 equals over 248, which means it's going to be 5,000 divided by 248, and that looks like this. Oops, backwards. I'm just going to round it off to one decimal place, and the x is actually going to be 20.2%. So any questions on those? They're pretty straightforward. We should plug it in the formula, right? Alright. I'm not going to spend a lot of time on these either, because basically it's an extension of what we just did. And also, we've seen solving complex fractions before, and it's basically the same process. So, I'll just review the process first. Then we'll do one example at least. So when they say complex percent problem, you're talking about this piece right here, because they have a fraction on the top now, where it's 8 1/3% of 150. So you put those in the equation, percent over 100 equals is over of, and it turns out like this. Perfect. But if we were doing cross multiply right now, what's going to happen is going to be 8 1/3 multiplied by 150 over 100 equals x. Right? That's what it would look like. We just did the shortcut way, and we took the 150 and multiplied by that, solving for x. We're all good? So, but then we're looking at 150 times 8 and 1/3. I hate that. So what do we do? Best thing to do is turn it into an improper fraction. So take the 8 1/3, 8 1/3, and turn it into 25/3. So, doing that, you can reduce it first, or we can just multiply 25 by 150 with this number, and divide by 3, and that becomes 1250 over 100. So basically it looks like this, 1250 over 100 equals x. And then if we want to, we can just come down here and take our 1250, I'll put a decimal right here, and bring it over after. 1250, and the decimal is usually right here at the end. Because we're dividing by 100, we're going to move it over 2 places. And that goes in there, and that equals our x value. And that's what they're trying to show you right here. So, they call it complex problem. So basically all it means is just another fraction there. And we know how to do that. The basic rules are the same, it's just cross multiply, take the fraction, turn it into, to take the mixed number or fraction, turn it into an improper fraction if you have to, and do the same thing as we've all been doing. Not really a big problem. We are screaming through this chapter. Just look, we're doing percent change now. So we basically have percent change, and we have two more sections to do, and we will be done this chapter. So this chapter is screaming by. So what will happen on Monday, because we have a test on Thursday. Monday I'll finish this chapter, then do chapter 6 as well, and then set up the testing situation for 5 and 6 next week. Sound good? Alright, just to review this one, I'm watching the time closely, but I'll just review this and then maybe that's all we get done here. It's not a problem. There is one little tricky part to this thing that I want to show you about. And sometimes they don't tell you. It's up to you to realize this, because it is a little nasty. The thing I'm trying to show you, or I want to show you, is right here. Excuse me. What they say here, they give you this formula, which is a nice little formula right here. Amount of change and over the original number minus equals the fraction of change. Okay? So down here they set it up, basically change in weight over original weight equals x over 100. Okay? So what they don't tell you is that this here, so I guess they say it, but they don't spell it out good enough, I don't think, because it's the amount of change. So if they left this piece of information out down here, they said the 12-year-old boy was told by his doctor he had to lose weight. Yeah, he was 180 pounds, he needs to be 120. So you have to actually take the 180 and subtract the 120 to get the 60 that they're using over here. Because it's a change in weight. Now they were nice in this question because they actually gave you the change in weight. You lost 60 pounds 1 year. But if they didn't give you that piece of information, you would need to know that. So you'd have to take the original weight, subtract the new weight, and then determine the change in weight. So then it's the change in weight divided by 180, which is original weight, that times 100, and then you get your percent. So then it basically comes down like this. We have 60 over 180 equals x over 100. Instead of breaking it down like they did here, I'm going to do it the way we're used to seeing it. So it's going to be 60 times 100 over 180, and the x comes out to be 33 1/3%. So again, it's not a real big problem because the equation is almost the same as before, but the only tricky part is right here with the amount of change. Make sure you get the difference in the change of weight. That's where 60 comes from. And that's the part that might trick you. Because the most common tendency is to take the new weight, put it over the original weight, and go from there. But we keep in mind it's actually the change. Perfect. And we are out of